So hey everyone, welcome back to my channel. Today's topic is classification of antibacterial agents. We will classify them on the basis of various aspects. Like first is chemical structure, on the basis of chemical structure. Then we will classify them on the basis of uh, they are primarily bacteriostatic or bactericidal. Then we will classify them on the basis of spectrum of activity, that is narrow spectrum or broad spectrum. Then type of organism, it acts antibacterial, antifungal, antiviral, antiprotozoal, antihelminths. Then we will see the mechanism of action, classification on the basis of mechanism of action. Okay, then another classification is on the basis of type of action, primary bacteriostatic or primary bactericidal. And last classification is on the basis of source it is obtained, whether it is obtained from fungi or bacteria or actinomycetes. So let's start. First is classification on the basis of chemical structure. Now, first is sulfonamides. Sulfonamides, we have sulfadiazines, sulfone-dapsones, and para-amino-salicylic acid. Then diaminopyrimidines, we have pyrimethamine and trimethorpine. Then quinolones we have norfloxacin, ciprofloxacin, nalidixic acids. Okay. Then tetracycline we have doxycycline. Okay. Then aminoglycosides we have streptomycin, gentamicin, amikacin, neomycin. These are all in the group of aminoglycosides. Beta-lactam antibiotics, this is very important. We have penicillin, cephalosporins, monobactams, and carbapenems. Then nitrobenzene derivatives, we have chloramphenicol. Macrolides are erythromycin, clarithromycin, azithromycin. These are all macrolides. Polyenes, there is nystatin, amphotericin B, and hemicin, something known as hemicin. But this is important, nystatin and amphotericin B. These are all polyenes. Then azoles is very important. Clotrimazole, ketoconazole, fluconazole, all the antifungal drugs. Okay. Then glycopeptides, there is vancomycin. Okay. Then nitrofuran derivatives, there is furazolidine, nitrofurantoin. These are all nitrofuran derivatives. Then nitroimidazoles, we have metronidazole. This is a nitroimidazole. Okay. Then there is tinidazole. Then lincosamide we have lincomycin, clindamycin. Then nicotinic acid derivatives. There is isoniazid, pyrazinamide, ethionamide. These are all nicotinic acid derivatives. Isoniazid, pyrazinamide. This is the regimen for what? You remember and comment. This is the regimen for what? Isoniazid and pyrazinamide. Then there is polypeptide antibiotics, polymyxin B, bacitracin, tyrothricin. These are all polypeptide antibiotics, polymyxin B, bacitracin. Then there is oxazolidine, linazolid is a oxazolidine, and others we have rifampin, ethambutol, spectinomycin, thiacetazone, griseofulvin. Okay. So first basis of classification is over, that is on the basis of chemical structure. Then the second basis is on the basis of spectrum of activity, whether they are narrow spectrum or they are broad spectrum. So in narrow spectrum we have penicillin G, streptomycin, erythromycin. These are all narrow spectrum antibiotics. And in broad spectrum we have most commonly used tetracyclines and chloramphenicol. Now in type of organisms on which they act, we have antibacterial, antifungal, antiviral, antihelminths, and antiprotozoal. Okay, antiprotozoal. So in antibacterial we have penicillin, aminoglycosides, erythromycin, fluoroquinolones. In antifungal we have griseofulvin, okay, amphotericin B, and ketoconazole. These are all antifungal. In antiviral very common, acyclovir, valacyclovir, amantadine, zerovodine, these are all antiviral. Antiprotozoal, there is chloroquine, pyrimethamine. You should remember in which regimen these are used and why they are used. Okay, metronidazole, this is the antiprotozoal. Many of you confuse metronidazole with an antibiotic. This is an antiprotozoal. Okay, diloxanide. Then antihelminths, we have niclosamide and diethyl carbamazine. Then on the basis of mechanism of action, whether they, first is inhibiting cell wall synthesis, we have penicillin, cephalosporins. Okay, cause leakage from cell membrane, we have nystatin, amphotericin B, polypeptide polymyxins, they cause leakage from cell membrane. Then inhibiting protein synthesis, tetracycline, chloramphenicol, erythromycin, they have the same mechanism of action, clindamycin. Then misleading of mRNA code and effect permeability, that comes streptomycins and gentamicin. Then interfere DNA function, DNA synthesis and DNA gyrase. Interfering DNA function, that is rifampin. Interfering DNA synthesis, acyclovir, and interfering DNA gyrase, fluoroquinolones. On the basis of type of action, primary bacteriostatic and primary bactericidal. Primary bacteriostatic, there is sulfonamides, tetracyclines, chloramphenicol, erythromycin, clindamycin, linezolid, ethambutol, rifampin. They are primarily bacteriostatic, inhibiting the bacteria from causing toxicity but not killing the bacteria. And primary bactericidal, there is penicillin, cephalosporins, aminoglycosides, vancomycin, metronidazole. These are all primary bactericidal. They directly kills the bacteria. Cotrimoxazole, ciprofloxacin, these are all primary bactericidal. Then comes the source, the origin of the anti-chemotherapeutic agents. So fungi, from fungi we get penicillins and cephalosporins. From bacteria there is polymyxin B, bacitracin and tyrothricin. And from actinomycetes we have aminoglycosides, macrolides, polyenes, tetracyclines and chloramphenicol. That's all.